For more than 4 decades, the Environmental Protection Agency has been leading efforts to inventory, assess, and regulate toxic air pollutants. Also known as hazardous air pollutants, or HAPs, air toxics are those pollutants known to cause cancer, respiratory, and other serious health effects. The 1990 amendments to the Clean Air Act currently identify 187 toxic air pollutants. These amendments are the basis for EPA's current approach of regulating sources that emit significant enough amounts of any of the identified pollutants. We come into contact with some of these pollutants every day: acrolein emitted from cars, industrial sources, and open burning; benzene found in gasoline; tetrachloroethylene emitted from certain dry cleaning facilities; and methylene chloride used as a solvent and paint stripper by a number of industries. In addition to man-made sources, air toxics are also released from natural sources, such as volcanic eruptions and forest fires. Part of EPA's mission is to reduce the amount of toxic air pollution in the air we breathe. Over the past several decades, EPA has issued regulations that have significantly reduced emissions of these hazardous pollutants from automobiles, trucks, and buses, as well as a wide range of industries. From large facilities like chemical plants, refineries, paper mills, and factories, to smaller operations such as gas stations and dry cleaners. There is still more to do. We need information about air toxics to understand where the problems exist. One way EPA obtains information about air toxics is by monitoring the air. To measure levels of air toxics, EPA places monitors in strategic U.S. locations. However, this network is not nationwide and monitors only a subset of the 187 pollutants. To obtain important information about air toxics at a national level, EPA developed the National Air Toxics Assessment, referred to as NATA. Since 1996, EPA has completed 4 national air toxics assessments. This comprehensive evaluation tool identifies geographic areas, pollutants, and emission sources that should be further evaluated to gain a better understanding of potential health risks. After further assessment, steps can be taken to reduce air toxic pollution. NATA starts with emission data provided by state, local, and tribal agencies. NATA includes the following emission sources: stationary sources, on-road mobile sources, non-road mobile sources, background, and secondary formation. Stationary sources include large industrial facilities such as power plants and refineries, as well as smaller sources such as gas stations, dry cleaners, outdoor burning, wood stoves, and fireplaces. On-road mobile sources include cars, trucks, buses, and motorcycles. Non-road mobile sources include trains, planes, ships, and construction equipment, even lawnmowers. Background sources refer to estimated levels of air pollutants arising from natural sources. Background sources also include pollutants that persist in the environment from past years' emissions, as well as long-range transport pollutants from distant sources. And finally, secondary formation. Also known as atmospheric transformation, secondary formation occurs when pollutants form from a series of chemical reactions in the atmosphere. Formaldehyde is one such example. To estimate risks from outdoor sources of air toxics, EPA scientists combine emissions data with the information about the locations of the sources and the numbers and locations of people living around the sources. EPA then uses computer models to estimate concentration levels and human exposure. From exposure concentrations, EPA estimates cancer risks and other serious health effects from breathing air toxics. The final result is a broad, comprehensive assessment of the risk of air toxics from outdoor sources across the entire U.S.
The EPA uses the NATA information in many ways, but primarily to prioritize our efforts to regulate emissions of hazardous air pollutants. We also use it to try to understand where we might do a better job of investigating sources of hazardous air pollutants and their impact.
By informing both national and localized efforts, NATA helps identify and prioritize air toxics, emission source types, and locations of greatest potential concern in terms of population risk. This in turn helps air pollution experts focus limited analytical resources on areas and/or populations where the potential for health risks are the greatest. By using NATA, states, tribes, and air quality agencies are able to prioritize pollutants and emission sources, identify locations of interest for further investigation, provide a starting point for local scale assessments, focus community efforts, inform monitoring programs, and prioritize schools for monitoring outdoor air toxics.
In addition, NATA provides information on the sorts of sources that are contributing to the concentrations and the risks in the community. For example, are most of the risks due to heavy industry? Are most of the risks due to smaller industry or to cars and trucks, for example? And that's the kind of information that isn't readily available through a community air toxics monitoring assessment. So NATA goes beyond what you might be able to get in a monitoring project.
When we get questions from the public or we get questions from our management about what areas in our region have high risk or high hazard, then we can use that to look and answer their questions. I mean, because we get a lot of different kinds of questions, a lot of varied questions about what's going on in Indianapolis, or what's the worst pollutant, or what's the biggest pollutant of concern in Columbus, Ohio. So we use it for things like that because it's an easy way to get a lot of good information quickly.
Communities have found that accessing NATA helps inform and empower citizens to make decisions on a local level concerning the health of their communities. In 2011, EPA released the results of its 2005 National Scale Assessment of Air Toxic Emissions. The 2005 NATA now provides information on 177 of the 187 Clean Air Act air toxics, plus a non-cancer assessment for diesel particulate matter. EPA's Science Advisory Board reviewed NATA and concluded that it represents an important step toward characterizing the relationship between sources and risk of hazardous air pollutants. Looking to the future, EPA continues to collaborate with state, local, and tribal communities to progress this critical evaluation and prioritization tool. Advancing methodologies, increasing the number of air toxics evaluated, and improving upon the health data collected are key elements in this progression. NATA continues to provide the tools and data needed to support both EPA's mission as well as state, community, and tribal efforts as we work together for cleaner, healthier air.